EAM of stream. And so that's fundamental to the Beam model to unify batch and stream. And data flow is one of the environments in which you can deploy Beam pipeline. You can also run them on Spark or on Flink or other open source runners. In data flow, what you get is a serverless execution model where you have nothing to install. You just submit your pipeline, and then we auto-scale it for you in batch mode or in stream mode, and you only use the resources that you actually need to process your job. And so that's really the kind of tool that is powering the transformation towards stream. Another aspect is PubSub, so upstream. Obviously, before you can process events, you have to reliably collect them and distribute them to subscriber. That's what PubSub does. PubSub, publish, subscribe. The pattern is very well known. There's nothing new about the pattern. What's new about PubSub is just like BigQuery, just like Dataflow. PubSub is a serverless system where you don't have to deploy anything, you don't have to scale anything. It is a global system managed by Google. All you have to do is create a topic and then start posting events and subscribing to the topic. And Google takes care all over the world of collecting the events, bringing them to the appropriate cloud data centers, and then delivering them to the consumers. And so that chain of serverless products from PubSub to Dataflow to BigQuery and its ability to ingest data. And of course, along the way, all the machine learning APIs are available to run queries on the data in stream mode or in batch mode to do natural language processing or video detection, anomaly detection. All of those things you can do on the fly as you ingest data and really build a real-time system into this next generation data warehouse. And since the theme of this event is really around the transition to ML, I want to point out another really important reason why you want a data ingestion and preparation system that works both in batch and stream without having to change your pipeline is that in machine learning, one of the things you have to do is prepare your data for training. Once you've trained your model, it's really important that the data on which you're going to run your model at prediction time goes through the same preparation steps. Otherwise, you get really unreliable results if you don't prepare that the same way. Well, most of the training happens in batch mode, and so you probably need a batch pipeline to do that. A lot of the prediction happens in stream mode, and then again, that's why you need that pipeline to be able to run in both modes. That's another benefit of Dataflow in that context. So here we go. So yeah, Dataflow, as I was mentioning, those three things are the unification of batch and stream and the operational excellence. That's what runs Google. And so in terms of optimization, efficiency, reliability, we have over 15 years of experience incrementally improving systems, and Dataflow is the result of that. Well, one customer example is Bright Cove, uses Dataflow and PubSub upstream heavily to, in real time, analyze video delivery pattern and usage and logs and get real-time information about what's going on. And we see that across all the customers. A big part of that is when they release a new update, when they introduce a new feature, when something changes, either on purpose or accidentally, they need to see right away the impact it has. So they know if it's good or not, they know if they have to address it, and they can take action. And that's what Dataflow provides as part of the move towards streaming. And so here's that same pipeline. One thing that you notice is that in addition to those blue hexagons, PubSub, Dataflow, BigQuery, which are a pure serverless cloud-native experience based on Google's technology, you also have options. So instead of PubSub, you have the option of running Kafka if you choose so. You can run Spark for your Dataflow pipeline. And so the platform is entirely open. So not only is Dataflow itself based on open source, you can bring other open source technology, and we make that very easily on the platform. One way we make that easily is via data connectors. And so ensuring that Spark and Hadoop have access, direct native access to cloud storage, to Bigtable, to BigQuery, and can be used as part of the platform. You don't have to choose between cloud native services and the best of open source. You can mix and match as you see fit. And so we've got an extra step to make that possible and easy, we've actually created a service, Cloud Data Proc, who is dedicated to bringing the best of open source data processing to Google Cloud as part and integrated with the larger platform. And so if you look at Data Proc, what it does is it will deploy a Hadoop or Spark cluster in Google Cloud. It will do that. It will do that very effectively and very quickly. And so you can deploy a pipeline in about 90 seconds. And at that, not a pipeline, a cluster. You can deploy a cluster in about 90 seconds. At that point, that cluster is ready to run. Because of the connectors I mentioned earlier, you don't have to worry about bringing data into Hadoop or into Spark. You just start that cluster and it starts working right away. It really changes, with that direct access to the data, with the speed of provisioning, with the per second billing model, it really changes the way people use Hadoop and Spark compared to on-prem. In one way, it doesn't change anything. It's the same Hadoop and Spark. So all your tools, all your pipeline just work unchanged. That's the good part. What it changes is the operational experience. And we see people moving towards much more dynamic cluster that you just spin up, do something, and then you can go on and continue and just shut them down or just do another task and keep them for a much shorter time period, and have different teams just create their own clusters as they see fit. It also, so that's kind of the foundation of it. The tool itself now supports workflows and the ability to automatically terminate a cluster after a job, or to terminate a cluster at a given time, or if it's been idle for more than a certain time. So we give you all the tools to really help you optimize your usage and bring the large ecosystem of Hadoop and Spark, but bring it in a way that is integrated and optimized on Google Cloud and can be used in conjunction with tools like BigQuery, like Dataflow, and like PubSub. So this is describing the storage integration, which I mentioned earlier. One thing I did not mention, which you can also see on this slide, is the integration with Stackdriver for monitoring and logging. And so all your cloud services, including Data Proc for Hadoop and Spark, are available or are monitored via Stackdriver. Gives you one place to have full visibility into all the execution, the performance of all those services. So trying to put it all together, I'm not going to walk through that entire chart. There's just way too much here. This is a recap. Some of the services here we talked about, others we did not talk about, and we have sessions as part of this event that go into more detail and lots of resources on the web. But this is kind of the overview of the data platform, the data processing platform on Google Cloud across the life cycle of the data, from the point of capture, pre-processing, typically with Dataflow, batch or stream, storage of analytics data in BigQuery, Bigtable for NoSQL, GCS for the global object store, all the processing system. We talked about BigQuery as a SQL engine, Dataflow, Dataproc, and ML engine in that context is, again, as we're saying, is another usage of the data that you brought for analytics. And then all the tools on the right side, partner tools, and as well as Google tools that provide really an easy and well-integrated access to the platform. And speaking of partners, I also did not mention the ETL and integration partners, very rich ecosystem of partners who can bring data from your on-prem application, from your SaaS services onto Google Cloud Platform. One thing that I want to finish with is that what I've described around serverless and the operational efficiency, that is transformational, and that's something that really we've been preaching for a long time, because that's how we run internally. It used to be misunderstood. It's now becoming front and center in the industry, and it was very validating to see this Forrester report focusing on Insight platform as a service, really another term for serverless or cloud native, and recognizing Google's performance as the best platform and the only leader for offering a complete portfolio of analytics services in the serverless model. So please have a look at this URL, has examples of more solutions. I just mentioned a few customers and how they use the platform. We have much more detailed information in those use cases. Please have a look. Please attend the other sessions. I hope you enjoyed the event, and thank you very much for your attention.
Welcome to the audience joining in from Big Data track.
Great.
And Jay, do you want to introduce the next track that we have for Big Data?
Sure. So the next track we have for Big Data is taking a look at data warehousing with BigQuery. So, there's lots of data that's being collected, and we talked previously about complex analytics and moving those to actionable insights. And sometimes those solutions aren't necessarily around machine learning. Sometimes there's easier ways or ways you can use as a managed service in order to get those actionable insights. And moving your data warehousing to a tool like BigQuery allows you to do that. So enjoy the sessions.
We'll see you right here after the tracks. And don't forget to ask as many questions as you have about the sessions. You have the Q&A button right on your left-hand side, the right to Jay. So yes, we'll see you again.
Hi, welcome back to Cloud on Air, the journey from big data to AI. I'm Dan McClary, product manager at Google, and now we're going to talk about reimagining your data warehouse using Google Cloud Platform. Now, IDC suggests that 163 zettabytes of data will be created by 2025. That's 1 trillion gigabytes. And in fact, debates are ongoing around what to call the next largest unit of data. It may be the brontobyte or the hellabyte. Now, that's an awful lot of data. However, as we think about our journey to AI, one of the things that's fundamental to it is that if you can't figure out how to integrate, manage, or use your big data, you may miss out on the benefits of machine intelligence. In fact, Peter Norvig's classic paper argues that part of the reason modern AI is as successful as it is because having a tremendous amount of data makes it easy to learn things. However, the Harvard Business Review reported in April of this year that organizations use less than 50% of their structured data to make decisions. More than that, they use less than 1% of their data, or their unstructured data, to analyze and make decisions. So the question then is, how do we find the tools and platforms necessary to help us make sense of huge amounts of data and growing volumes of data in a really simple fashion? Well, one of the ways we can think about this is by thinking about modernizing our data warehouse, thinking about what we've done in the past and what we want to achieve on our journey to AI, and what role does the data warehouse play in that? Now, what better way to perhaps demonstrate what it might be like to have a modernization of our data warehouse than to actually analyze some data about where to build a warehouse? In this case, we're not going to talk about a data warehouse. We're going to talk about a physical warehouse. So let's take a look. Now, you can see here I'm in Google BigQuery, which we're going to be spending a lot of time talking about today. And I have here a data set around retail data. I have customers, I have dates, I have products, I have locations, I have lots and lots of sales. Now, you can see it's a relatively complex schema. It's got things around baskets of orders and their prices and things like that. But the thing I want to point out to you is here, when we look at the size of it, this sales data alone is 1.09 petabytes. That's a huge amount of data. Well, gosh, if I wanted to figure out where to put a new warehouse location, I'd probably want to go through and look at my historical sales and understand where that data might go. Well, I've prepared a query to help us take a look at how we might do that. So let's see. Here we go. One of the nice things about a system like BigQuery as a modern data warehouse is it keeps track of the queries that you've run, so it's easy to figure out what you're looking for. Now, I'm going to look at that petabyte of sales data. And what I'm going to find out here is I want to figure out what are the locations in which my customers are paying the most in shipping, because those are places I might want to put a new warehouse to reduce their shipping costs. So I'm going to go ahead and run this query. And as it's running, well, it was cached. That's not fair. That's cheating. Let's turn off caching so that we can actually see how fast BigQuery really is. There we go. Now we're running. Now, let's take a look at this and figure out what we're doing with our modern data warehouse. I'm taking a look at all of the orders that I've had over time and figuring out what the average cost of freight was. Then I'm taking that and scaling down profit to understand millions of dollars. And then beyond that, we're going to figure out what things look like year over year. I'm going to get the top 10 results. Now, I look at these top 10 results, and you can see very quickly places where people are paying a little bit over $6 in shipping. New York, Houston, Sacramento, El Paso, and that only took us 17.7 seconds. So that's a petabyte of sales data analyzed in 17 seconds. Pretty impressive. So I just did that using BigQuery. But what is BigQuery? Well, BigQuery is Google Cloud Platform's data warehouse. It's encrypted, durable, and highly available. It offers the convenience of standard ANSI-compliant SQL, as you just saw. But it also allows things like real-time analytics on streaming data. BigQuery can ingest tens of thousands of rows per second per table, and you can analyze rows exactly as they arrive. Now, the other thing you'll notice is that BigQuery is in fact petabyte scale, since we just analyzed a petabyte of data. And one of the things that makes BigQuery interesting as a modern data warehouse is it's fully managed and serverless. There's no infrastructure to manage, no hardware to provision, and very little in the way of DBA activities. You simply manage your data. You don't manage the system internals. Now, when we think about what this means, the benefits of Google BigQuery are distinct from what you might find in many existing data warehousing offerings. Now, first and foremost, it's scalable. As we've just shown, you really do get true multi-petabyte scalability, and we've in fact been battle testing the underlying technology in BigQuery for over a decade. It's also really, really simple. As you saw, I can simply go to a web interface, type in a query, and analyze data. You can also access it from a number of popular platforms in BI, ETL, and through a REST-based API, and numerous developer libraries. So between serverless simplicity and a host of access methods, it's really, really simple to integrate BigQuery into your workflow. One of the things we'll look at is it's very easy to share data in BigQuery. One of the things that we've found at Google is very important for helping teams get the most out of their data is making it easy to share relevant data with other groups of collaborators while maintaining security and control over them. And one of the things about BigQuery that really changes the game for modern data warehousing is that you can almost always save. Our fully managed service offers lower TCO than most systems, and you can choose the kind of billing you want to incur, whether it be pay-as-you-go and only for the work that you do, or a fixed flat rate fee. So let's dive a little bit into the architecture of Google BigQuery and talk about what makes it so special. What you see here is BigQuery's architecture. Now, we've decoupled storage and compute, and this is a powerful concept when we think about big data. When big data became a bit popular, one of the things that we often talked about was data is really big. We have to move compute to data because moving data around on networks is just tremendously costly. Now, open source projects and other organizations have tried to mimic some of the magic of Google's Dremel engine, which is what we started working on here over a decade ago. Dremel is Google's data warehouse. Over 80% of Googlers use Dremel on a daily basis. And with BigQuery, what we've done is we've taken the Dremel engine and added managed storage. But because Google's internal networks are so fast, what you get is the ability to have your storage and compute separate and still receive lightning-fast processing. This allows you to make very interesting decisions about where you place data. And importantly, you don't have to choose to provision storage specific for amounts of compute. You don't even have to necessarily use BigQuery's own storage. You can use a host of other GCP storage products and still access them using BigQuery. Now, beyond that, we offer numerous ways to load data into the platform, free bulk loading, streaming ingestion at tens of thousands of rows, and again, all of the sort of access methods you would expect out of a data warehouse built both for today and tomorrow. Now, let's talk a little bit about that managed storage. While BigQuery has millions of cores at its disposal to process your data using SQL, it also manages your data storage for you. And you get high availability and exceptional durability with BigQuery's managed storage. Data ingested into BigQuery is transformed into a columnar format and then stored within a region in multiple locations. This means that you don't have to worry about making a backup copy of your data or deploying a second instance to keep your system up and running. BigQuery handles all of that behind the scenes for you at no extra cost. So those are the internals of BigQuery at a high level. Now let's talk about what makes BigQuery different from a user experience and why it helps you on your journey to modernizing the data warehouse. So as a modern data warehouse, we think that BigQuery does some unique things. So just to point some of these things out, automatic data delivery is a huge part of BigQuery's value proposition. Rather than getting an empty box of servers that you have to stand up either on your premises or in another cloud, BigQuery will bring data in for you, either through public data sets, commercial data sets, or data transfer from Google managed sources like AdWords, DoubleClick, and YouTube. And we've talked a bit about sharing. Democratizing your data insights is an important step on the path from big data to AI. BigQuery allows you multiple ways to share and control access to data, as well as multiple ways to consume that data for people of every kind of analyst class. Put those two things together and you really start to build the foundation for AI. But we've gone a step further and worked to make sure that there are easy integrations with multiple popular ML platforms. Now, I've mentioned it before, but BigQuery's ability to handle real-time insights through streaming ingestion and SQL queries on top of that data allow you to take advantage of the fast-moving world of mobile data, as well as the coming wave of IoT data. Now, beyond that, you can protect your business data between our durable, highly available storage and compute, as well as our 99.9% SLA. What you end up with is a very robust system with nothing for you to manage. And we've worked very hard to make sure that BigQuery meets many regulatory requirements, so it's likely right for your environment. All of that, paired with our serverless and fully managed capability, allows you to really simplify your data operations. You'll spend less time tuning systems, deploying infrastructure, and trying to figure out how to size things, and more time analyzing big data and laying a foundation for a machine intelligence-driven workflow. So let's drill in just a little bit. Automatic data delivery means that you get faster time to insight. It means that you can take the data that you have and you can bring to it the data you wish you had. Our automatic transfers from sources like AdWords and YouTube mean that you can get data delivered on a daily basis from systems you haven't been able to analyze before. Our shared public data sets and shared commercial data sets mean that you can go out and find the data that you need, or maybe data you didn't even know you needed, and bring it to bear on your analyses. And then finally, BigQuery has a unique ability through its separation of storage and compute to federate queries across all of GCP. This means that you can access data stored in Cloud Bigtable, Cloud SQL, Data Store, a number of other places, even Google Drive. Thus, you can actually get a real high-level view of all of your data from one spot. So let's take a little bit of a look at what automatic data delivery might do to the way we analyze data. And for that, I'm going to go ahead and return to our question about where should we put a new warehouse. Well, I've determined that I have a number of candidate cities that I might want to build a new warehouse in. But one of the things I know that my collaborators are going to want to know about is environmental impact. Well, I don't really know anything about environmental impact, I'll admit that. But BigQuery public data actually includes a set of EPA air quality data from most of the US. I could join that together with my findings and actually figure out maybe what are the air quality metrics I would want to share with my colleagues. Let's take a look. Here we go. So very simply, what I've done is I've gone and I've looked for this data set, EPA historical air quality. And so I've got an air quality annual summary. Well, with that, I can very easily say, for the year 2016, give me the parameters and arithmetic means for that data as it relates to the locations that I vetted as a candidate. Let's take a quick look at what that produces for us. Oh, there we go. Now, I'm not necessarily sure if these metrics are good or bad, but I do know that my collaborators will have a better sense than me. And so now, by joining public data, I've brought richness to my analysis that I can rely on my collaborators to help me make better decisions. Now, this automatic data delivery is really, really powerful, but it goes much beyond public data. We have the ability to both directly import data into BigQuery for you and to federate queries against other sources. Now, on the direct import, again, we have public data. We have data like Google Analytics, AdWords, YouTube, exports from Cloud Data Store, and soon from Cloud SQL. Now, federated query provides a unique capability to reach out and query live systems or archival data stored in GCP or in G Suite. So, for example, you could store archival data in Google Cloud Storage cold line and query it with BigQuery when you needed to. This is a great way to keep your long-lived archival data at a low price per byte without having to compromise on how you analyze that data when you need to. If you have a number of spreadsheets floating around your organization, you can place those in Google Drive and query them with BigQuery. Thus, you can actually have your analyst class collaborate with the people writing spreadsheets in your organization so that you don't have shadow data hiding inside. So let's talk about that democratization. Some of that democratization means that we can actually cast a wide net over the data assets stored within the warehouse and beyond. But some of it is also allowing you to power the business applications that you need to run your business today and the ones that will enhance your productivity tomorrow. Now, BigQuery provides connections with most of the popular BI and ETL tools, so it should fit seamlessly into your workload. And again, using our platform connectors and our direct data import, you can bring your siloed data sources together in a way that is unique. Now, you can also share data with other organizations by allowing them read-only access, or what we call authorized views, which exclude certain data from certain eyes. Now, we want to make sure that everybody has ways to democratize data in their organization. And as I mentioned, some of this has to do with partner tools, MicroStrategy, Tableau, Informatica, the popular tools you may use today. But we also want to make it very easy for organizations to share data more broadly at no additional cost. Two of the ways we do that are through Google Sheets and through Google Data Studio. Now, we allow you to take results from Google BigQuery and immediately export them into Google Sheets with a click of a button. This makes it very easy to prepare quick spreadsheets for other parts of the business. But you can also power Google Sheets with BigQuery, allowing you to make fixed, up-to-date spreadsheets that your organization can use without worrying about data quality. Now, beyond that, for people who want to report and create beautiful visualizations, Google Data Studio is a free tool that we offer that allows you to make beautiful reports using data from BigQuery, Cloud SQL, and a number of other popular analytics tools. So let's take a little bit of a look at what it might be to democratize data and share some of these results. Let's think about our warehouse case one last time and think about what it might be to visualize and share results. So I've gathered some information on air quality for my site locations, and I've gathered some potential site locations. But I probably don't want to just hand 2 SQL queries to my colleagues and say, there you go, guys, run with it. Instead, I'd like to make a report for them. So let's use Data Studio, a free tool that Google offers, to pull something together. Now, I'll admit, I've already started working on a report, but we're going to go in and edit it as well. So I've started my warehouse locations report. And I was able to add the 2 data sets that I've been working on around air quality and retail sales for warehouse locations into that report as data sources. It takes a couple of clicks. But what I'd like to do now is go in and add maybe a map of where the sort of total sales volume is. So all I do is I go and I grab a geomap, I drop it in here. And I'm going to use my warehouse's location data source. We're going to use the place name as my dimension. And then let's go ahead and use profit in millions of dollars. And just like that, you can see I've got a lovely map of the US with bubbles for each of the locations. Well, that's nice, but when I share this report with people, they're probably going to want to look at individual candidates and individual metrics for things. So what I'm going to do is just group this the same way I would in a spreadsheet kind of, or a slide kind of tool. I'm going to group them together, which will allow this data picker to actually filter things for me. Let's just take a quick look. So here's my map of the US. Here's some of my particulate information. And let's say I want to look at just the city of El Paso. Now I can see the total opportunity in El Paso and the different levels of air pollutants measured in that city. So that's a great way to share data with our collaborators, make it really, really easy to share things through Google Drive at no additional cost. Now, we're on the journey from big data to AI. And with BigQuery, we've taken great strains to make sure that BigQuery is the best place to store your structured data for building that AI foundation. Now, one, because much of the data you're going to analyze is structured. BigQuery's ability to store and efficiently process that large amount of data to refine is fundamental to AI. But beyond that, we want to make sure that you can use the machine learning tools of your choice to build that foundation. And as such, BigQuery has worked to offer a native TensorFlow reader, high throughput integration with SparkML through Google Cloud Dataproc, as well as a number of client libraries that allow popular machine learning frameworks such as scikit-learn and MXNet to plug directly into the system. Again, real-time insights are going to be even more important on your journey to a real-time AI-driven business. As events arrive faster and faster, you need to be able to analyze things in real time. BigQuery allows you to stay responsive and be in the know because you can always query the most up-to-date data, even as it streams into the system live. The other thing that we want to make sure of with BigQuery is keeping that total cost of ownership in check. As I mentioned, in many cases, you will save using BigQuery. And so you're going to get great value for money with amazing cost for performance. And you're going to pay only for the resources that you need. You pay only for the storage that you need and only for the compute that you use. And as I mentioned, you can choose your payment model. You can either pay as you go for the resources that you use, or you can get a simple flat rate price for your whole organization and never worry about overages and billing. And best of all, you can get started for free. BigQuery offers a generous storage free tier that allows you 10 gigs of free storage and a terabyte of data analyzed every month. And that means that the data we analyze today might actually have been free. And we have a vast ecosystem of partners, ranging from data ingestion SaaS providers to traditional ETL and BI partners. Beyond that, you'll find that next-generation analytics companies like Trifacta and Cool Data are built to integrate closely with our platform. And we have a wide variety of service providers that you can leverage to help you get started on BigQuery today. So let's talk a little bit about a few customers who've made the journey from big data to AI using BigQuery. So the first company I want to talk about is Ocado. Now, you may not know Ocado if you live in the US, but they're a major grocery provider in the UK. Now, they've migrated almost all of their business platform, over 100 terabytes of data, to GCP. And BigQuery is that central data warehouse for them. Now, along the way, they have real-time data processing needs because, again, groceries are moving all the time. Logistics never sleeps. And they use Dataflow for batch processing pipelines and our Google Cloud PubSub system to message data across the platform. And the results for them have been astounding. They've seen over 1,000% sales conversion on thousands of products. And this means over £5 million a year optimized in spend and for their long-term customers. Bottom line, that's better ROI for them and reduced damaged orders. So more inventory is going where it needs to go and staying unbroken. Now, when we think about the benefits of automated data transfer, MultiChoice is a great example of this. MultiChoice is using our data transfer service to bring in sources from many Google managed services. So MultiChoice, as a telecom provider, has over 8 million customers. And when they moved to BigQuery, they brought together over 27 data sources. Now, when we think about that ability to manage structured and unstructured data from across your organization, you probably have 27 or more data sources. MultiChoice shows that it's possible. This data was no longer in a silo. They had a single view of the data estate. And so what this amounts to is over 2 billion rows of data, and they now have a unified custom view of what their customers are doing, and they're able to aid their product and marketing campaigns to make better decisions about both their ad spend and how to reach their customers. And finally, let's talk a little bit about Zulily, the popular e-commerce site. So Zulily has a fast-changing business. Inventory is different every day. Sales are different every day, which means that they have to stay up to date to serve their nearly 5 million customers. So on a given day, they may have 100 events and 9,000 different product styles. And by integrating their data with Google BigQuery and using that as the analytics workhorse for their recommendations and their product placement, they find that they were able to connect and analyze all of their data using a scalable architecture that didn't force them to capacity plan for specific boxes and specific storage sizes. And BigQuery's ability to handle real-time ingestion and real-time analysis meant that they can really keep up with the pace of their rapidly moving sales environment. And so with that, I'd like to remind you to get started with Google BigQuery for free. All you have to do is go to cloud.google.com/BigQuery, and that'll let you try out BigQuery using our generous free tier for free. Now, beyond that, I hope you've got some questions about what we've talked about so far, because there are experts standing by ready to answer your questions. And stay with us for the rest of the conference, because we've got a lot of great content coming up. Thanks.
Welcome. We're welcoming all the guests, all the audiences that have been attending the big data session, which was around reimagining data warehouse with Google BigQuery, what's new and what's next. So did you watch that session, Jay?
I did. So thank you so much, Dan, for that session. It was really useful. BigQuery is actually, one of those cool products that that really changes how you think about big data. The fact that it's really just about uploading your data and querying it, right? So you don't have to worry about building indexes. You don't have to worry about building out clusters in order to support the SQL queries, in order to support your data warehousing. It all just kinds of happens automatically underneath as a managed service. So you can have a petabyte of data, just write your query, and it all happens for you. But I guess the next question is, how do you get it in there in the first place? So actually in the session coming up in the big data track, we've got simplifying ETL with streaming analytics, which is also a very cool session and actually includes one of my favorite products. So definitely check out that track if you have the opportunity.
Awesome. And next, joining us, we have our audiences from the AI track, where they just finished up a crash course on the machine learning APIs that we have at Google Cloud. Did you get a chance to watch that one?
So yeah, so not at this time. So I actually watched this one during the Australia-New Zealand session. So Sarah Robinson did this one. It's a really good introduction to the machine learning APIs. So if you don't have a bunch of data scientists on hand, and you don't have a bunch of PhDs in order to build those models, you can actually use some of the things that we've built for you. So a lot of pre-built solutions that you can just call the API, get the information that you need, and use those just by introducing those tools to your developer team.
That's correct. And what I particularly loved was about the video intelligence API, because that is really something unimaginable. Like if I were to watch a 1-minute video, I would probably be able to remember only about 50 things. But that's what the video intelligence API does. It completely maps out every single thing that you see throughout. So that's amazing. And I think the next session coming up in the AI track would be the reimagining conversational experience with the cloud speech and dialogue flow. That's really interesting, Jay. We've seen a lot of use cases and customers for that in India as well. So yeah. I think that should be one session to watch out for.
Yeah, chatbots in Southeast Asia are a very big topic. And if you're familiar with API.ai, it's been rebranded as Dialogflow. So you'll have a really good introduction there to Dialogflow and how it can be used to build those chatbots in a really sort of drag and drop kind of way.
Really interesting. And next, joining us are the industry solutions track audiences who've just finished attending a session on accelerating delivery of healthcare solutions with Google Cloud and AI. And the next on that same track is the future of financial services, cloud, and machine learning. So I think this is something really interesting, Jay. What do you say?
Yeah, I think for both healthcare, where they've just come out, and financial services, the most interesting there is both of these are heavily regulated industries. So the ability of those industries to leverage what Google Cloud can bring or what the cloud services can bring is extremely important. And those companies that can figure out how to leverage that the fastest and the best are going to be one step ahead of the competition. And in fact, there's a statistic that essentially 38% or companies across industries can expect an increase in profitability by 38% by introducing AI to their workflows.
Wow, that's some figure. So we'll let you guys go back to the sessions, go back to all the 3 tracks that we mentioned, and we'll see you once you're done.
Great.
All right, welcome back to Cloud on Air, everyone. My name is Kier. I'm the product manager on Google Cloud PubSub, a stream ingestion service. And with me today, as is the tradition now, is
Sergey Sokolenko. I'm a PM on Cloud Data Flow.
Now we're continuing our journey from big data to AI by talking about how you actually get the data into these beautiful systems that we've heard about. So BigQuery and ML Engine. We will talk about the pattern, which is stream analytics, and about the tools that make it easy on Google Cloud Platform. So you may have heard a talk that we've given a couple months back. This will be a different version. We'll have a new demo, and we'll try to give you a little bit more depth in terms of showing how the tools work. You can refer for more details to that talk as well.
And I think one of the interesting patterns, especially for AI, would be streaming predictions. If you would like to do predictions on your data, streaming is kind of a central component of this architecture. Don't you think?
Absolutely. And so it's worth clarifying that streaming it's very much about real time. It's from being able to take in data that used to take maybe hours and maybe days to ETL and take decisions on and make predictions. It's about taking it into maybe seconds and actually making predictions in real time, right, in seconds, and making decisions as you go along. But it's not just about that, and I think that's kind of the core part of the story, right? It's not just about real time. It's also about taking some of the sort of the classic ETL challenges that all of you, I'm sure, are familiar with, and simplifying them with stream analytics tools. So the way we'll do the talk is we'll do a little bit of an overview. We'll explain what we mean by stream analytics. Then we'll spend the majority of the time on Sergey's exciting sentiment analysis demo. I can't wait to share this with you. And then we'll show you how a customer of ours uses these tools in production in a critical kind of environment. So let's get to it. So as we mentioned, this is about real time. Right. Let's just be clear. Real time is what's seconds, right? This is what we're talking about. Data about events in the real world from when they happen to when you can do something about them using the machine learning tools, things like BigQuery and so forth. Examples abound. It doesn't really matter which industry you're in. Everything is kind of moving to real time. Certainly if you're in retail and advertising technology, absolutely critical there. In media as well, IoT has become a big use case. And in all of these cases, you have two types of problems. You have the classic ETL, right, where let's say in retail, you may have your inventory system, and you may want to take data out of that inventory system and sort of ETL it into a database that backs some kind of recommendation service, right? So you have a view of your inventory. But you also have this vast stream of small events that you might be using for things like fraud detection or recommendations, like clicks and taps. Which things are people, which pages are people viewing? Which products are they seeing? So combining these kind of classic ETL things at large scale and doing them in real time and simply with this vast stream of data to be ingested to be into systems that can actually understand it and make predictions is the name of the game.
And the demo we're going to show will actually address one of these use cases where you have streaming online interactions of your customers with your retail sites, and you do something with them to moderate the online comments.
Right.
All right, so among all these customers in various industries, the steps that we saw are particularly applicable to streaming analytics. Start with ingesting and delivering real-time updates. And many customers here are using your product, Cloud Data Flow, to do exactly that. Now, once data is ingested from a event stream and gets routed to a processing infrastructure, many of our customers are using Cloud Data Flow to do time-based aggregations. They calculate statistics. They do various kinds of counts and averages and stats based on time windows. In addition to using Cloud Data Flow for orchestration, there's also a set of tools that that are used for managing your jobs, your streaming pipelines. A couple of tools come into mind. Apache Airflow is a very useful tool to do orchestration of jobs. Now, so far, we've been talking about how customers are moving the data and focusing on streaming to move data from sources to sinks. But batch processing still has a role in this process, especially if you have, for example, historical data that you would like to onboard and mix with your real-time data. Or another example would be you would like to reprocess all the information, all the events you've streamed into your sink and apply different business logic. That's another case where batch processing is important. And at the end of this data processing pipeline, we're seeing customers using data warehousing a lot. BigQuery is a big and important tool there. But we also see more and more customers are using AI systems and machine learning systems